right, number 8, we have hydrogen reacting with C2H4 to give us C2H6. So hydrogen, we've drawn this Lewis structure many times. Hydrogen single bonded to the other hydrogen, and we only have one of the H2 molecule. Then we have C2H4. Hydrogen never goes in the middle, so all we're going to do here is bond those 2 carbons together in the middle and distribute the hydrogens equally. So 4 hydrogens total means each carbon gets 2. Just like that. And then let's look at our remaining electrons here, because we do need to double check to make sure this is a single bond and not a double or triple bond. So there's our skeletal structure. Each hydrogen came with 1 valence electron, 1 times 4, plus each carbon comes with 4, 2 times 4. So 8 plus 4 is 12 total electrons. This structure has 2, 4, 6, 8, 10 electrons. So we used up 10, we have 2 remaining. So let's look at who's happy and who still wants more electrons. Well, the hydrogens are already happy because they each have 2, a duet of electrons. Carbon here only has 2, 4, 6, so this carbon on the left is unhappy. And this carbon on the right also only has 6, so he's also unhappy. They each would want 2 more, but we don't have 4 to give, we only have 2. So instead of giving each carbon 2 separate electrons each, we need to share those last 2 electrons. So that means we need a double bond in the middle to use up our final electrons. There's our Lewis structure there. Then coming on over to the other side, this time we have C2H6. So once again, our carbons are going to go in the middle, single bonded to each other. Then we're going to split up those hydrogens, so each carbon is going to get 3. Hydrogen, put those hydrogens around. But then once again, we do have to double check to see if this is a single bond or if it's going to be a different type of bond in the middle. So this time we have 6 hydrogens, so 6 times 1 is 6, plus 2 times 4 is 8. So this time we have 8 plus 6, so 14 total electrons. Let's look at how many we've used up. 2, 4, 6, 8, 10, 12, 14. So we've already used all 14 electrons. Let's double check to make sure everyone's happy in this structure. Every hydrogen already has 2, and then this carbon has 2, 4, 6, 8, so that carbon is happy, and the other carbon also has 8, so the other carbon is also happy. So this structure is correct as is. Now we just need to look at our different types of bonds and add up our bonds and cancel them out. The first type of bond that I notice is this hydrogen-hydrogen bond. Hydrogen-hydrogen bond. And I see one of those bonds on the reactant side. The next type of bond that I see on the reactant side is this carbon-carbon double bond. And I have just one of those as well. The third type of bond that I see on our reactant side is this carbon-hydrogen bond. And I have 1, 2, 3, 4 of those. And that takes care of all my bonds on my reactant side. Looking over on the product side, let's see first if we have any hydrogen-hydrogen bonds. Don't see any of those. And let's see if we have any carbon-carbon double bonds. We don't, because we have a carbon-carbon single bond instead. I'm going to circle that in a new color, carbon-carbon single bond. We have just one of those. And then carbon-hydrogen bonds, well, we do have a whole bunch of carbon-hydrogen bonds on our product side. So we'll do those in the same color, carbon-hydrogen. We have 1, 2, 3, 4, 5, 6. Wow, 6 of those, and that takes care of all of our bond types. So we can cancel out some of these carbon-hydrogen bonds. If we have 6 on our product side and 4 on our reactant side, this 4 is going to completely cancel out. And then instead of having 6 that we need to add into our math problem here, we only have 2 of those left. So that simplifies just a little bit. These are canceled out. Let's add up the hydrogen-hydrogen and the carbon-carbon double bond. Let's see, hydrogen-hydrogen is 436. plus the carbon-carbon double bond is 614 for a total of 0, carry the 1, 3, 4, 5, and then 6 plus 4 is 10. A total of 1050 on our reactant side. So let's say reactants. Okay. And then on our product side, we have this carbon-carbon single bond, which is right here, 348, plus 2 times carbon-hydrogen single bond, which is 413. 2 times 413 is 826 plus 348. Add those together. 8 plus 6 is 14. 4 plus 2 is 6. Plus 1 is 7. And the 8 plus 3 gives us 1174 on our product side. So now we just need to do reactants minus products to get our final answer. Reactants is 1050 minus products 1174. To get our final answer, let's grab our calculator. Let's see. 1050 minus 1174 gives us negative 124. And our units, of course, are kilojoules. Let's box in that final answer there. There is our problem. All right, number 9, we have C2H6, which we did already draw this Lewis structure. C2H6, it's the 2 carbons bonded together, and the 6 hydrogens around them. So we have this Lewis structure once, and we actually have 2 of them, but instead of drawing this twice, because this would take up a lot of space, I'm just going to put that coefficient 2 in front. So however many bonds I end up here, I'll multiply it by 2. Then we have O2, which we've also drawn before. We know O2 is oxygen doubly bonded to another oxygen with those lone pair electrons, 2 lone pairs on each oxygen. And we have 7 of these, and I really don't want to draw this 7 times, so I'm going to put a 7 out front of it instead. On our product side, we have CO2, which we've drawn before as well. Carbon goes in the middle, and we know there's double bonded oxygens on our carbon dioxide. And then each oxygen gets 2 lone pairs. We have 4 of these, so I'm going to put that coefficient 4 out front there. And then last we have H2O. Oxygen goes in the middle, the hydrogens go on either side, single bonds, and then we get 2 lone pairs of electrons on the oxygen. And we have 6 of these, so I'll put that 6 out front. So this method saves you a little bit of drawing, but you do have to be careful to make sure that you are counting bonds correctly if you do this, because we can't circle all of the bonds. We're just going to have to go back and multiply by these coefficients here. Let's start counting bonds. We have carbon-hydrogen bonds, so I noticed that. Carbon-hydrogen bonds. And I have 1, 2, 3, 4, 5, 6 times that 2, so 12 total carbon-hydrogen bonds. Then I have this carbon-carbon single bond right in the middle here. Carbon-carbon single bond. We have 1 times 2, so 2 of those types of bonds. And then, lastly, I have this oxygen-oxygen double bond. Oxygen-oxygen double bond. And I have 1 of those times that coefficient of 7, so I have 7 of that type of bond. Then on our product side, let's first look to see if we have any of the same types of bonds. Carbon-hydrogen, I don't see any of those. Carbon-carbon, I don't see any of those either. Oxygen-oxygen, I don't see any of those either. So we have totally different types of bonds on our product side. I see carbon-oxygen double bonds. Carbon-oxygen double bonds. I have 1, 2 times 4, so 8 of those. And then I see oxygen-hydrogen single bonds. And I have 1, 2 of those times that 6, so 12. Now I need to look up all of these values separately. Carbon-hydrogen, 12 times 413 will give us some answer. Carbon-carbon single bond. Let's see. Carbon-carbon single bond is 348. 2 times 348 equals some answer. Then oxygen-oxygen double bond is 495. 7 times 495. So let's get some of this added up here. Let's see. 12 times 413 gives us 4956. 2 times 348 gives us 696. And then 7 times 495 gives us 3465. Now I could probably add these up in my head, but I'm not going to because I'm feeling a little bit lazy and I have a calculator here. So I'm just going to go back and add all three of these values together, which gives me 9,117. So those are the values for my reactants. And I know I need to subtract out the value for my products. So let's figure out what that is. Carbon-oxygen double bond, 799, 8 times 799. Then oxygen-hydrogen single bonds are over here, it's 463. Let's do some math. Do 8 times 799. Gives me 6,392. And then 12 times 463 gives me 5,556. We'll add those two values together to get 11,948. So those are the values of my products. Now let's move that over here. Reactants minus products minus 11948. That'll give me my final answer. So let's see. 9,117 minus 11,948 gives me negative 2,831 kilojoules. I'm going to move that answer over here so I have room to write it. Negative 2,831 kilojoules. That is my final answer here. Alright, our last problem here. We have CH4. Hydrogen's not going to go in the middle, so carbon is. And those 4 hydrogens will go around that carbon. There's my Lewis structure, and I only have one of those, so I don't need to draw it more than once. Plus Cl2, chlorine. Each chlorine is going to have 7 valence electrons times 2, gives me 14 total. When I draw my skeletal structure, I've used up 2, so I have 12 left. And fortunately, each chlorine wants 6, so I can give each one of them 6 lone pair electrons to make them happy. Then I have 3 of this Lewis structure, so I'm going to draw this 2 more times. Then on my product side, draw my arrow here, I have CHCl3. It's telling me that the carbon's going to go in the middle, and then we're going to have a hydrogen and 3 chlorines bonded to it. Alright, then we only have one of those, so we're good. And then we have HCl. So there's really only one way this can be drawn. HCl. Has to be like this, but let's check to make sure this is a single bond. Hydrogen comes with 1 valence electron and chlorine comes with 7. So we have 8 total. We use 2. We have 6 left. Hydrogen's already happy with those 2 electrons. Chlorine wants 6 more to be happy, and we have 6 to give chlorine. So this is perfect. And we have this Lewis structure 3 times. So I'm going to draw HCl 2 more times for a total of 3. Now that we have all of our structures drawn, we can look at our types of bonds. I'm going to go ahead and draw a dividing line between my reactants and my products here. Let's see. I see carbon-hydrogen bonds on my reactant side. And I have 1, 2, 3, 4 of those bonds. And then the other type of bond that I see is chlorine-chlorine single bonds. And I have 1, 2, 3 of those types of bonds. Then on my product side, I counted everything on my reactant side. I'm going to look for similar bonds. Carbon-hydrogen. Carbon-hydrogen, I do have a carbon-hydrogen bond. So I have just one of those types of bonds. Chlorine-chlorine, hydrogen-chlorine, carbon-chlorine, but no chlorine-chlorine bonds. Alright, so new types of bonds now. We have carbon-chlorine. And I have 1, 2, 3 of that type of bond. And then I also have hydrogen-chlorine bonds in my acid. 1, 2, 3 of that type of bond. Alright, so now let's add up some numbers. Carbon-hydrogen, I have 1 on the product side and 4 on the reactant side, so that 1 can cancel out completely. Now I only have 3 that I need to add up. Let's do that first. Carbon-hydrogen, let's find that in our chart, 413. 3 times 413, and chlorine-chlorine, 242, 3 times 242. So let's get some answers here. Let's see. Turn that on. 3 times 413 is 1239. And then 3 times 242 gives us 726. And if we add those two answers together, our total for our reactants is 1965. Alright, then on our product side, we have some new values. Carbon-chlorine, let's see, maybe I'm covering it up. Carbon-chlorine, I am not seeing this. Carbon-chlorine, right here, 328. And then hydrogen-chlorine, let's look, HCl 431. Let's see here, getting our calculator out. 3 times 328 gives us 984. And then 3 times 431 gives us 1293. If we add those two values together, we get 2277. So there's our products. So then to find our final answer, we need to do reactants minus products. So let's see. 1965 minus 2277. Let's get that final answer. 1965 minus 2277 gives us negative 312 kilojoules. There is our final answer for our last problem.